Right, oh dear, there we go. So morning everyone, my name's David George, I work for IBM, and I'm here to you this morning to talk about developing Watson cognitive applications. So a little bit of a pointer because IBM is massive. This is where I work. I'm part of the Emerging Technology Services team based out of our development lab in Hursley in sunny Hampshire, where we work on first-of-a-kind proof of concepts. Right? What we do is we take interesting technologies from research and from our research partners, and we try and do exciting things with them. The other hat that I wear at IBM is I'm also one of the lead developers in Watson Group's tooling team, where what we do is we build tools which help developers to configure and train the types of applications that we're going to be talking about today. So first of all, the level set. What do we mean by cognitive, or what do I mean by, say, cognitive? The human brain is an amazing machine, and it lets us interact with the world around us. It can take in massive quantities of information. It's able to put all that information into context, analyze it, and let us decide how we're going to act upon it. And it does it continuously, in real time, and most of the time without us even knowing that we're doing it. You guys are all doing it right now, even as I'm talking to you. That cognitive process is powered by a framework which is common to all humans, and it looks a little bit like this. It starts at the top where we observe the world around us. We take it in through all our 5 senses in all the forms that's available to us. We interpret that information. We put it into context. We try and relate it to our accumulated knowledge, the things that we've experienced and the things that we already know about. And once we've done that, we then come up with a set of options of how we're going to deal with that information, how we're going to act upon it. And we try and anticipate the consequences of us acting upon that based on our accumulated experience. And then once we've done that, we make a decision which we're able to act upon. And once we've acted upon it, we observe the outcome of that, and then the whole cycle begins round and round again. This is common to everyone, regardless of our level of experience or our trade. And the more often we execute this loop, in the ideal world, the better our decisions become, the more experience we gather, and we become an expert in our particular field. But it's becoming increasingly challenging for us as humans to execute this loop. It's an often quoted little fact that there's more information been produced in the last 2 years than the entire preceding history of mankind. Things like the internet, things like the Internet of Things and sensors, social media means there's a lot more information out there than we can possibly observe all at once. And there's more contextual information out there in the world than we can possibly make sense of. So what we need is help. We need assistance in making sense of all that data and executing this cognitive loop. So when I talk about a cognitive application, what I'm talking about is an application which embodies one or more parts of this cognitive cycle so that it will enable us to execute it at the speed and scale that's required of us in this day and age. Okay? Jeopardy. Now, I'm from IBM, and I can't talk about cognitive computing without mentioning Jeopardy. So IBM's first big showcase of cognitive computing was when we put the original Watson computer on the American game show Jeopardy up against 2 of its human champions. Watson won $1 million for charity that day by winning the match, right? And it was one of IBM's grand challenges, like playing chess against Garry Kasparov before it. And grand challenges are something of a tradition for IBM. It's what we do when we want to show that we can push the boundaries of technology. We can use cutting-edge research to achieve things that we didn't think were possible before. Now, something like this, something like a computer, which is able to understand natural language, understand human, very kind of nuanced phrases and questions, and then find the answer to those questions in a massive corpus of unstructured data, is not something that you tackle head on. You need lots of different capabilities, and you need advances in those fields in order to achieve it. So you need text analytics, you need natural language processing, you need big data technology. Sorry, Jonathan, about that. You need big data technology in order to execute those things at scale. And you need to tie it all together with the latest in multiprocessor technology, okay? But once you put all those things together, all those capabilities, you have this new capability, right? You have a cognitive capability, which you're able then to take and apply that to other domains. And that's what IBM is doing with Watson. So now it's graduated from research, and we're using it to do all kinds of things. We're using it to help build cancer treatment plans. We're using it to do clinical trial matching. We're using it to help manage wealth and to scale expertise in call centers and in retail. But IBM realizes that it was not going to come up with all of the use cases for this technology on its own. It's really, really exciting. And a lot of the exciting new use cases are going to come from outside of the company. So what we're trying to do is give developers the ability to add these cognitive capabilities to your applications. And the way that we're doing that is through the Watson Developer Cloud. Okay? The Watson Developer Cloud is a set of services which we've built to make available that will allow developers to mix in cognitive capabilities into the applications that they're building. Right? It's a set of services. It looks like this. And they're all services which help with different parts of that cognitive cycle. So for example, the observe phase is helped by something like the language translation service, right? It lets us take in information in different languages so that we can then put it into context in later stages in the one that our application understands. There's a service for concept insights, and what concept insights does is it lets us understand the underlying concepts in a piece of natural language, both the ones that are explicitly stated in the text and also ones that are implied by the text. And once you have the underlying concepts, you can do broader searches of information than you would be able to do with just a keyword search or something like that. And you have things like natural language classifier, which lets you take natural language and then relate that to a set of pre-trained classes and texts so that you can work with them after that. Some of these services are now generally available. They're ones that you can take and use in your applications today. And some of them are in beta or early access phase. We're trying to make them available to developers as early as we can so that they can get a feel for how they're going to work and have ideas about how they're going to use them in their applications. And some of the applications are trainable. You can configure them to operate in a particular problem domain, like natural language classifier. You can give it its own set of classes from your own problem domain. Okay. Ooh. There's a big green button on this remote, and it doesn't work. There we go. Okay. So here's an example of us using these services. Okay. Watson at Wimbledon, right? So a lot of you will have heard of the Wimbledon tennis tournament, okay? It's a tennis tournament. It's hosted at the All-England Lawn Tennis Club in London. And for a quarter of a century, IBM has worked with Wimbledon to help them scale from a members-only tennis club to what is essentially the center of the sporting universe for 2 weeks out of the year, right? We're talking about mobile applications, we're talking about cloud hosting, we're talking about sensors and analytics. And every year we try and push the boundaries a little. We try and do a few things that we weren't able to do the previous year or in previous years. And that's the part of it that my department, the Emerging Technologies Department, likes to get involved. One of the things that we were looking at this year was access to information. We wanted to make it easy for people that wanted to ask questions about the tournament or find out information about the tournament to find that. And the way that we did that was with a two-pronged approach. So Wimbledon is a tennis tournament, okay? And tennis is a sport like any other, and sports produce massive amounts of structured data. So just by playing the sport of tennis, you create structured data, okay? You have things like match scores, you have things like player seedings, you have player rankings, that kind of thing. But now we also have things like instrumentation on the courts. You have all of the data and the telemetry that's coming from the courts, but you also have all the analytics that's associated with that. So we have things like serve speeds, we have things like percentage of ins and outs and faults, right? Now, we have an idea already. We know, or we're quite good at taking information and visualizing that structured information, and we know how to query that. So this is a picture of Slam Tracker, which is our way of letting viewers explore the data that's coming from matches at Wimbledon in real time, and then also to explore historical data about it. But Wimbledon isn't just about the sport. It's not just about what's going on the court. You've also got things that are going on off the court. Wimbledon is something of an institution now. It's hosted in summertime. People eat strawberries and cream. They drink Pimm's. You have celebrities that go and sit on the court. People go to see celebrities. They go to dress up. Sometimes the celebrities sing a cappella medleys when it rains, that kind of thing. And you have all these things which generate and contribute to the rich sort of history about Wimbledon. And that history is documented in things like news articles, things like blog posts, social media, the official compendium that gets published about Wimbledon every year containing all of the data. And people want to ask questions about this stuff. They want to know about this stuff. If something interesting happens at Wimbledon, they want to go and see if it's happened before and that kind of thing. And they want to query all of this information using natural language, okay? And the system that we came up with was, it looked a bit like this. Now, I can't take credit for this analogy. This was come up by one of the Wimbledon team. But it's almost like a brain that comes in two halves, right? You have a half of the brain that's very, very good at answering questions about statistical knowledge. It knows about who won the tournaments which year. It knows how many players have the most faults, or which player has the fastest serve, for example. And you have another side of the brain, which is very, very good at general knowledge questions. It's good at answering questions like how many strawberries get eaten at Wimbledon every year, where do the strawberries come from, that kind of thing. When did they put the roof on centre court, that kind of thing. Okay? And at the front of that, you have an interface, a kind of frontal cortex, if you like, right, to continue the brain analogy. And that's responsible for making sure that the questions that come in get answered by the correct side of the brain. So the solution that we came up with looks at a more detailed level like this. There we go, right. It's a system of 3 parts, and the 3 parts are named after Sherlock Holmes characters, kind of continuing on the Watson sort of theme. So the right-hand side of the brain, the general knowledge side of the brain, if you like, is played by Watson, specifically Watson Engagement Advisor. This is the same application that powers the question and answer service that you can use on the Watson Developer Cloud through Bluemix, our platform as a service. Okay. If you ever talked about how a Watson system works, at a high level what it does is it breaks down questions, natural language phrases, into the entities and concepts that it knows about in order to generate queries, right? It generates many, many queries that it then goes off and runs across its corpus of the things that it knows about, this unstructured data that it knows about. And at that point, what it's doing is it's trying to find as many candidate answers as it can for a question as it possibly can. It's going for quantity over quality, because if it doesn't get the answer, the right answer, in that first kind of sweep of the corpus, it's not going to find it later. And what it does once it's got all of those answers is it goes back off to the corpus and it tries to find evidence to support each one of its answers, all right? And once it's done all of that, it analyzes all of those, it ranks all of the answers and comes up with a level of confidence for each of them, how confident it is that it's managed to answer the question correctly. And what we do with this system is we take the best answer, the most confident answer, if you like, and we return that back to the system that's calling it. The other side of the brain, the left-hand side of the brain, the one that's really, really good at stats questions, is played by a system called Hudson, which was something that we built in emerging technology. What Hudson uses is a research technology called controlled English. Very briefly, what controlled English is a subset of the English language which lets you model things that you know about in your problem domain, like so entities. So in this case, we're talking about things like players, courts, matches, that kind of thing. And it lets you relate those things to records in your structured data stores, whether they're your DB2 databases full of match data or whatever it happens to be. When Hudson gets a question, it looks at the question the same way and breaks it apart. And this time, it looks for the entities that it knows about mappings to, and it goes off and generates queries for its structured data stores, and it brings you back the answers. And again, it gives you back a level of confidence for each answer, and it returns that level of confidence back with the one it's most confident into the main system. At the front of that all is a user interface called Hopkins. Hopkins is a kind of chat user interface. You give it questions and it gives you back answers. This is how people kind of think that they're going to interact with a cognitive system. It's partly because of Jeopardy, because people expect to ask questions and get answers back. So when Hopkins gets a question, what it does is, first of all, it looks to see if it's a question that's frequently asked and it already knows the answer to that, so something that's kind of right on the tip of its tongue, if you like. And if it doesn't, what it does is it sends it to the two halves of the brain. right? Both halves of the brain have a crack at answering the question, and it sends both of the answers back to Hopkins. And based on the level of confidence of each of the sides of the brain, it chooses which one it's going to present back to the user. So the result of that is a nice system that looks like this. So here's the chat interface. You can ask it questions like, who won last year? Okay? And when you ask the question, who won last year, that question is something that's going to be better answered by the statistical part of the brain. It has all the rankings, it has all the win-loss records for the tournament, and it can tell you who won each of the tournament rankings last year, so the men's, the women's, and the pairs. You can ask it questions like, what is the capacity of centre court? Now, that's not something that's part of the kind of tennis record, the sporting record, but it is something that's in the unstructured data, something that's in the unstructured corpus. So that question is better answered by the Watson side of the brain. So the answer you get back there is a passage from the corpus of data. You can also ask it questions that have different representations. It was something that we had to go at to see if we could show answers in better ways. So for example, if you ask the question, where is centre court? The structured side of the brain knows that that is in a particular location, and it returns you back a lat long. When Hopkins gets back a lat long like that, it says, that's a location, that's a place. And the response that you get back in the user interface is, I think I better draw you a map. And it goes off and it renders a map from a mapping service and presents that back to the user. So that's something that we tried to experiment with. Now, this is just a start. This is a kind of a long-term project that we see running at Wimbledon. So it's something that we're going to be working on over the next few years. But it's a good way of showing that you can incorporate cognitive capabilities even when it's a domain like structured data, when you already kind of have a good idea of how you're going to present it. Now, building a system like that still sounds like it's an awful lot of code to write, right? It's an awful lot of difficult things to try and do. But it doesn't necessarily have to be that way. Now, I'm going to take a slight tangent now and talk about some Internet of Things technology, but I promise I'm going to bring it back onto point at the end, okay? So I want to introduce you first to this. This is NoDread, okay? NoDread is a technology that was developed by a couple of colleagues of mine in emerging technologies, Nick O'Leary and Dave Conway-Jones. And it's what it says. It's an open source project, and it is a visual tool for wiring the Internet of Things. It's designed to make it easier for people to build connected applications, Internet of Things type applications. It is a JavaScript application that's designed to run on Node.js, as the name suggests. And what it gives you is a web user interface that looks like this, okay? And on the left, you can see there's a palette of what we call nodes, right? A node represents something that you commonly would want to do in an Internet of Things application. It might be listening to the serial port on the side of your device for something that you've plugged into it. It might be listening for inbound HTTP requests. You can build a basic sort of web server or REST server with the tool as well. And it might be listening to message queues. And you've got output nodes beneath that to send messages out to the same sorts of things. So publish messages out to a message topic, send it to a device that's plugged into your machine. And in between that, you've got logic nodes that will let you transform and route the message. And the object of the application is to build what we call flows, right? So data comes in on the left and it goes out on the right. So what I've got here is a very, very basic NoDread flow. We've got an inject node, which just lets you trigger things. By default, it'll send in the current timestamp, but you can customize it to send any message you want as you like when you press the little button. I've got a function in the middle that does something, and then the result of that function goes out to the debug tab, which is on the right-hand side. So when you press the button, the result of that function appears in the debug tab, right? It's really, really simple to use, and it's really, really powerful, right? And it lets you compose applications using Internet of Things devices really, really easily. Now, that idea of composing things together fits really, really well with a platform as a service where you have lots of different capabilities that you want to bring together in an application. So rather than just being available on as a download from GitHub, this is also available as a boilerplate on our platform as a service, Bluemix. So you can click on a button on Bluemix and you can have a NoDread instance running in the cloud in less than a minute, right? There's some things that don't necessarily make sense in the cloud, so things like a serial port, you can't plug something into the cloud. But when you have services in Bluemix, like the cognitive services that I was talking about earlier, The nodes are all service aware. They know about how the nodes work, and they know how to talk to them properly, and they know about your account and everything else like that. So it makes it really, really easy to do. So in the Bluemix version of NoDread, it supports a lot of the services that are available in the Watson Developer Cloud. So we talked earlier about language translation, the Q&A API where you can ask it questions and get back answers, the text-to-speech services, relationship extractions. They're all there to be able to be wired into NoDread flows. So it makes it really, really easy to drag and drop and to experiment with these new capabilities. So an example, bringing that all together, this is an application that I built using Twilio, using Bluemix, and using the Watson Developer Cloud Q&A service. It's a Twilio service, so when Twilio receives a message to one of my Twilio numbers, it sends the message to this HTTP endpoint that I've registered with Twilio. I store the inbound SMS details, and the idea of this application is that it's an application that people can text their medical questions to. It's something that you might use if you were writing an application for a GP surgery, or it's something, you know, whatever your problem domain is. The service on Bluemix for question and answer supports healthcare questions, and it supports travel-based questions, so you might be able to text questions about your holiday destination to it. It sends the question answer and API, and coming out of that, I have a node which checks the level of confidence that Watson had in that answer. And if it's above a certain threshold, I send it back by converting it to an SMS length, by truncating it. I convert it back to the format that Twilio needs, and I send it back. And the user, the person who texted it in the first place, gets a message on their mobile device with the answer to their question. If Watson wasn't sure about the answer, and I can set the threshold wherever I want to set it, it will send back a custom message that says, I'm not quite sure about this answer. It adds a little addendum that says, I'm not quite sure about this, but, or you might want to say, I'm not going to return you an answer at all, depending on your application. Once it's assigned that, it goes through the same flow and it sends an answer back. Now, I kind of missed a trick when I was building this application a week ago. I could have also incorporated something like language translation in it. That would have worked really, really well in the travel-based example, because then what I could have done, my inbound message could have been in any language. I could have identified which language that was in, translated that into English, so it will work with my question and answer API, and then once the answer comes back, translate it back into the language that the original question came in, to text it back to the user. So there's loads and loads of different ways that you can use these services, and really the sky's the limit as to what kind of thing you can build. So, in summary, cognitive applications are ones which support the human cognitive process. They embody parts of that cycle that I showed you earlier, and lets us execute that cycle at the scale as required of us today. And we can add cognitive capabilities to conventional applications, right? It can be a new capabilities that we add to an application that we already have. And you can do that using the services that are available using the Watson Developer Cloud and IBM Bluemix, okay? So what will you do with Watson? Thank you very much. Okay, does anyone have any questions about what I've just told you? Or anything in general? Stunned silence. Fantastic. Oh, yes.
I'll ask a quick question. So earlier on I was messing around with data sets and discovered some balloon flights in a very large set of records. Would Watson allow me to make that data set available, push it up into the cloud, and then simply ask the question, are there any balloon flights in this data? Is it at that level of sophistication yet, or do I need to do some coding first to shape it up?
That's a good question, and it kind of depends largely on which type of Watson you're using. So there are lots of different Watson products which you can use outside of just the developer cloud here. So there's Watson Engagement Advisor, which is very, very good at finding answers to questions in unstructured data. And the way that a Watson system performs, any Watson system performs, is going to depend on the kind of training that you give it, right? So you will train it to ask the kinds of questions that your users are going to ask. All right, so that's that kind of question. And the idea of those is to capture knowledge, to capture expertise, and let people ask questions in the way that they would to someone like a subject matter expert. Then there's another product called Watson Discovery Advisor. And what that's for is to try and surface patterns in data in the same way that you're talking about there. So trying to discover information that you might not otherwise have seen. And that's the kind of use case that we're talking about there. So I think the answer to your question is yes, it can do that, but you need to choose the solution that's right for the problem that you have. Excellent. Okay. I think it's coffee time. I know there's a developer session next, an open session next, and I know there's an open area out there with post-it notes that people can write suggestions for subjects on for the next session. So while you're out there having your coffee in a minute, do go and grab a post-it note and come up with ideas for what we can talk about after our coffee break. Okay. Thanks very much.